Welcome back again, my celebrity nation. Today we are looking at our lecture 4 in Physics 102. Method of charging a body. Remember when I was talking about in charges, when I say production of charges, we said there are 3 ways of producing charges. Today we are looking at those methods one by one. There is no other person here than your celebrity teacher, Dr. UD Jesus. Fasten your seatbelts. Let's do what we know how to do best. Lecture objectives. At the end of this lecture, you will be able to know the 3 basic ways of charging a body. Charging by the method of friction, charging by conduction, and charging by induction. And you can comfortably explain each one of them. That is the target for this lecture. So at the end of the lecture, you'll be able to tell me whether you are able to do these things. Now, previous lecture revision. In our previous lecture, we took care of classification of solids based on energy band gap. So we discussed conductor, insulator, and semiconductors. And what are conductors? We say that conductors are those materials that allow the passage of electricity. Insulators are materials that do not allow the passage of electricity. While semiconductors have an intermediate conductivity between conductors and insulators. What does that mean? It simply means that sometimes semiconductors behave like a conductor and sometimes it behaves like an insulator. Looking at the diagram down there, let me use it for a better illustration to explain what we're saying. If you look at the insulator, you will realize that there is a large energy band gap between them, between the valence band and the conduction band. That energy band gap will not allow electrons from the valence band to move to the conduction band. So the system cannot conduct electricity. Now, if you come at the middle one, which is, okay, let's go to the right first, which is conductor. You will realize that there is no energy gap. The valence band and the conduction band overlapped. So electrons move easily from valence band to conduction band. So the material conducts electricity with ease, without stress. Now the middle one, which is semiconductor, you can see there is energy band gap, but it's small. And what does this do? The energy band gap stops it from conducting electricity. On its natural state, it's not a conductor. But when it acquires energy, such that electrons from the valence band gains more energy than the energy band gap there, it moves into the conduction band, and that makes semiconductor to conduct. So that is why sometimes it does not conduct and sometimes it conducts. So semiconductor reacts as an insulator and sometimes reacts as a conductor. That's the revision of our previous class. In fact, you've taken an advantage of that class. But if you want to have a full lecture of that class, it's still available. Check for it and have a full lecture. It's a wonderful lecture. Now, let's go to the lecture of today. Methods of charging a body. There are 3 major methods of charging a body or generating charge. The very first one is by friction. Here we'll have 2 bodies rubbing on each other. The second one is by conduction. Conduction is where 2 bodies just come in contact to one another. I will explain all this in details. Then the third one is charging by induction. Charging by induction doesn't require any form of contact between the body that is to be charged and the body that is charging it. It doesn't require contact. Now let's look at them one by one. Charging a body by friction. In this pattern of charging a body, two neutral bodies are brought together, rubbed on each other to make them electrically charged. And how does this happen? When one body is rubbing on the other, one of these bodies rub off electrons from the other one. Remember, initially they were neutral. Each of them was neutral. So that means, since they are neutral, it means that the proton number is equal to the electron number in both of them. So if I give an example, if I'm using a cloth, just like the diagram there, rubbing a plastic rod, what will you see? The cloth will rub off some electrons from the plastic rod. That means that the cloth now, which you are having, has extra electrons on it, while the plastic rod, which you're seeing, has lost some electrons. Now let's look at this example. If I have my plastic rod rubbed by a cloth, just like the first diagram you saw, before the friction, what do you see? Both of them are insulating neutral materials. There is no charge there. The net charge in both products or in both materials are zero. But now, something is about to happen. After the friction, what do you realize? Since the cloth have rubbed off some electrons from the plastic rod, you now see the cloth containing some electrons, some negative charges, which means it now have more negative charges than it used to. While the plastic rod have lost electrons, thereby having more positive charges than it used to. So, in essence, what do we see? The cloth is now negatively charged, while the plastic rod is positively charged. This simply means that both neutral elements coming together to rub themselves have acquired opposite charges. Both of them are charged now, but in opposite way. What do I mean? The cloth is charged, but negatively charged, while the plastic rod is also charged, but positively charged. So, by the process of friction, we've been able to charge two neutral insulating bodies. This is the process of friction. So you can charge a body by the method of friction and gain two opposite charged bodies. The next one we'll look at is charging a body by conduction. Here, a neutral body is charged by coming in contact with an already charged body. Because when you put two neutral bodies together, since the net charge in both of them are zero, there will be no reaction. But now, I have a neutral body, just as in that diagram. I have a neutral body. And now, I bring a rod that is negatively charged and touch it to it. What do you think will happen? Because the rod is negatively charged, the negative charges of the neutral body will run away from where the rod is touching, because like charges repel. And what happens next? Since we have free negative charges on the rod, they will be attracted by the positive charges in the neutral body. So they will run into the body. When you now remove the rod, they cannot jump out of that body. What happens? More negative charges are now in that body than it used to. So it's no longer a neutral body, but a negatively charged body. This process is called charging by conduction, where a charged body charges a neutral body by mere contact. Charging a body by induction. This one is quite different. Because in the other two we've discussed, both in friction and in conduction, there is a contact. But in induction, there is no contact. If you are charging a body by induction, you don't require contact between the body that is to be charged and the body that is charging it. Here, a neutral body is charged without any form of contact with the charged body. Rather, the charged body is held close to the neutral body without contact, such that the opposite charges to the charged body will cluster nearer. Remember, unlike charges attract. So when you bring a negative charge very close to a neutral body, what happens? Positive charges will run close to where that body is, while the like charges to the charging rod will run to the other end of the body. So now you have achieved that. Negative is closer if you are charging with negative rod, and positive is the other end. But the question is, how will you now, if you remove the rod at this moment, what happens? All of them will mix up together again and continue. So, but if you want to achieve a charged body, two things you would do. Either you separate that body, the one that have already given a negative charge and a positive charge on the other side. If you separate it, you get it. Or you can use anything to etch, maybe touch it with a finger so that the positive charges will leave. The body becomes negatively charged. Without much talk, let me illustrate further on this with a diagram. I think you will understand better there. Okay, for example, let's look at this diagram so that I don't bore you with long talk. The two diagrams A and B at this point are neutral. You can see it yourself. Now, a rod that is positively charged is brought close to two of them. What do you see? Because the rod is positively charged, the negative charges in both systems will run to the first one, being closer to the rod. Why? Because unlike charges attract. While the positive charges will run to the other one, the reason like charges repel is running away from the positive charges from the rod. So it will be on B, while negative charges will be running closer. So it will be on A. Now, without contact, as that thing is still there, separate the two, A and B. What happens? The A will now circulate only negative charges inside it, and B will circulate only positive charges inside it. So by mere induction, you have generated two charged bodies. One is negatively charged and the other one is positively charged. This is called the process of induction. You can also do another process of induction using this diagram here now. Let me also explain this one. The same way, but this time around, I have only one neutral body. Now, if I bring the charged body, which is negatively charged now, to it, what do you see? Since it's one body, the negative charges cannot run to another body. No, they will stay there, but they will stay behind, showing that something is repelling them, something is casting them away. Why the positive charges will be closer to the rod because something is attracting them. Now, all of a sudden, you can use any metal, any conductor, or your finger to touch on that part where you have the negative charge. What happens? Earthing will occur. All of them will run down through that process. And what will remain in that system is just the positive charge. Even if we'll have negative charge there after that. But it's obvious that the positive charge will be more in number. So we'll say that that body having more positive charge now than the negative charge is positively charged. This is another method of induction that I have explained to you. Now let's proceed. Talking about our lecture review, I have taken you on a lecture how to charge by friction, how to charge by conduction, and how to charge by induction. I hope you're very comfortable with this. If you are not, the very first one, charging by friction, occurs when two insulating neutral bodies were brought together and rub on each other, such that one rubs off electron from the other. The one that gains the electron that is rubbed off becomes negatively charged, while the one that the electron was rubbed off from becomes positively charged. And I gave you an example. You can also go through this lecture again for better understanding. Then the second one, charging by conduction. This one is a charged body charging another neutral body by contact. When you place a charged body on another body that is neutral, the charges of that body that is opposite to the charged body will run close to it, while the ones that are like to the charged body will run to the other end. And because the charged body you have is free, they will run into the neutral body. And when you remove your charged body, you have a charged system. Now, charging by induction. In this one, there is no form of contact between the charging body and the body that is to be charged. Rather, you bring it closer to it for the charge to occur. Thank you for listening. Our next lecture will be on Coulomb's law. Today we have learned how to charge a body, and we'll say there are three: the friction, the conduction, and the induction. If there is anything at all you think you did not understand, or there is a deeper learning you want to have, kindly drop it as a comment in our comment section. Drop it as a feedback so that we will be able to treat that and make you feel comfortable with this Physics 102. Once again, thank you very much and have a glorious day. Meet you in our next class. Thanks.